Problems in asking us to minimize or maximize something are called optimization problems in general. This is an example of one of those. This time we're going to be asked to minimize something. In this case, they have a furniture company's determined that X hundred wooden chairs are built. The average cost of each chair is given by this function here. And the C of X, the answer that we would get out of that, is in hundreds of dollars. Okay, so in other words, 1 for my X would represent 100 chairs. And when I plug that in, the answer would be in hundreds of dollars as the average cost per chair. We want to know how many chairs should be built in order to minimize that average cost. Well, we look at the leading term here. It's a quadratic, it's a parabola. Look at the leading term, and because it's positive, we know it opens up. If I have an upward opening parabola, then I'm going to have a minimum occurring at my vertex. That's good because I'm trying to minimize the cost. We need then to find the vertex. All right, I'm going to use the formula the opposite of b over 2a. So x is equal to, why is it positive? Because I want the opposite of the negative 0.7 over 2 times 0.1. That reduces here. Now, you could do this in your calculator, or you could just multiply top and bottom by 10 and realize that's 7 divided by 2, or 3.5. Now, it doesn't mean I'm doing 3.5 chairs. Remember, it's X 100 wooden chairs, so I take 3.5 times 100, and that gives me 350 chairs. Now, if they wanted me to tell them what the average cost per chair is, I would plug that in and then multiply my answer by 100 to give them the cost.